Hello my dear students, welcome to IMS GATE Academy. A warm good evening to one and all. So in the last class, we have discussed regarding communication subject first three chapters. Regarding first three chapters, we have discussed various questions. So I hope all of you got the contents regarding first three chapters of communication system subject. So those who couldn't attend yesterday's class, so you can watch that session later in your free time. So today we are having the second session regarding communication system subject. So this subject is common for two branches, EC and instrumentation. So in the last class, we have discussed regarding the questions related to the first three chapters. So in this particular session, we are focusing the questions related to the last four chapters. Right? Here, chapter 4 and chapter 7, these two chapters are not there for instrumentation branch regarding the syllabus of communication system. Okay, only chapter 5, chapter 6 will be there. But here in this particular session, we will focus the questions related to these four chapters in a sequence. Okay, right. Yeah, very good evening one and all. So how many of you are ready for today's session? How many of you are ready to solve the first question of today's session? Yes, very good. Venkatramana, yes, very good. So all of you kindly share this video link with all of your friends so that they also will attend this session in live and they also will get benefited from this session. Yes, very good Rohit. I hope all of you are eagerly waiting for the session. So let us start the first question. So this is the MCQ. So that means only one option will be correct. Only one option will be correct. So now first we are focusing the questions related to the fourth chapter. Yeah, other students also please try and share your answers. I will disclose the correct answer in some time. Yes, very good, Venkatramana and Rohit. Yes, very good. Very good, Jagdish. So here they have given the information like this. If x is a random variable and they have mentioned regarding this random variable, the distribution is uniform, uniformly distributed in the interval 3, 6. This is something like a, b. So for generalized case, if you assume a, b, so in that interval it is uniformly distributed. Then they are asking the mean and variance of the random variable x. So regarding that, they have given 4 choices. You have to choose the correct one. If you remember the formula, directly you can substitute the values, you will get the answer. Okay. But for the time being, I will derive regarding mean and regarding variance. So this particular derivation will be helpful whenever they give some probability density function. That time, if you want to find the mean and variance. So for that sake, first let us derive the mean and variance formulas. After that, I will substitute whatever the a value, b value they have given in those standard formulas. So from there you will get the answer. Okay. So first let us consider regarding probability density function fx of x of uniform distribution. Say for example, so x-axis I am considering the variable random variable x and y-axis I am considering fx of x. So for the timing I am considering AB on x-axis like this, and here they have mentioned the distribution is uniform, uniform distribution. Okay, so between A and B you are having constant value. For the timing I am labeling as x. I hope all of you know the standard formula regarding integration of probability density function. What is the value you are going to get? I hope all of you know this standard formula regarding integral minus infinity to infinity fx of x dx. Yeah, Venkatramana, regarding median and mode, okay, you will study in the probability in the mathematics subject, but in the communication subject we will use mean variance only, mean and variance. So in the probability concept, mode is nothing but whatever the number is repeating more number of times, that particular value is nothing but mode. I hope all of you know this formula. What is the equivalent value? Equivalent value is nothing but 1, right? Integral minus infinity to infinity fx of x dx is equal to 1. But here you are having between a and b only. So that means from minus infinity to 0, the fx of x value is 0. From b to infinity also, fx of x value is 0. Only between a and b you are having some constant value, right? So that means I am considering only the interval from a to b, and you are having constant value k dx is equal to 1. So here k is the constant, you can keep k outside the integral, then integral a to b dx is equal to 1. So integral dx is nothing but x, and here the limits are a to b, a to b. So substitute these limits, k into b minus a, upper limit minus lower limit. So its equivalent value is equal to 1. So if you do the simplification, you will get k equal to 1 by b minus c, 1 by b minus c. So here I have assumed that one as constant, but after using the standard relation, so this value is nothing but 1 by b minus c, 1 by b minus c. See, it is very simple. Here integration is nothing but what? Whenever you are performing integration, integration is nothing but whenever you are supposed to find the integration of any curve or signal, integration is nothing but area under the curve, area under the curve, right? So here if you observe, simply you are having one rectangular shape, rectangular shape. So regarding rectangular shape, area is nothing but what? Area is nothing but length into breadth. Okay, here the duration is nothing but b minus a, b minus a. Okay, b minus a. And here height, for the timing I am assuming it as constant k. So area under the curve should be equal to what? 1. Area under the curve should be equal to 1. So from here, k value you are getting 1 by b minus c. K value is nothing but 1 by b minus c. So you can use the integration. After that, what is the relation you are getting? Same answer you will get if you are just calculating the area under the curve. Both are same. Both are same. Right? So now, so this k value we got. So that means from here you can write regarding the fx of x, probability density function, fx of x is equal to 1 by b minus a for x lies between a and b. For x lies between a and b. Otherwise 0. Otherwise 0. So this is the probability density function fx of x. Okay. I hope it is clear for everyone regarding uniform distribution, how to get the probability density function fx of x. Okay. Now once if you get fx of x, now we can calculate expectation of x. Expectation of x is nothing but mean value or average value of the random variable x. So expectation of x is equal to integral minus infinity to infinity x into fx of x dx. X into fx of x dx. So here just now we got the interval from a to b only. Okay, interval from a to b. So here I am considering the integral starting from a to b, x into fx of x value just now we got 1 by b minus c. 1 by b minus c into dx. Okay, 1 by b minus a is a constant. You can keep outside the integral. Then integral x dx is nothing but x square by 2. I hope all of you studied regarding differentiation and integration in your mathematics. Integral x dx is nothing but x square by 2. Otherwise, just do the derivative of this one. X square is nothing but 2x dx. 2 will get cancelled. You will get x dx. Right? In the similar way, you can cross check. Okay. So now the limits are a to b. Just substitute the limits. So denominator you are having 2 into b minus a. Numerator you will get b square minus a square. B square minus a square. So just write the stand. B square minus a square is nothing but b plus a into b minus a divided by 2 times b minus c. So here b minus a will get cancelled. So you are getting b plus a by 2. So this one, if you want, you can write it as a plus b by 2. So that means it is very simple. Whenever you are having the uniform distribution like this, average value is nothing but just you have to consider average of these two. A, b. Average is nothing but what? A plus b divided by 2. Right? So that is nothing but expectation of x or average value or mean value. All are same. So you can put this one in the box. So expectation of the random variable x of the uniform distribution is nothing but a plus b by 2. A plus b by 2. Okay. Now similarly, let us calculate expectation of x square. Expectation of x square is equal to integral minus infinity to infinity x square into fx of x dx. X square into fx of x dx. So here also limits we are considering from a to b. Other than a to b remaining interval, you will get simply 0. Okay. X square into, once again, fx of x is nothing but 1 by b minus c. 1 by b minus a into dx. Now 1 by b minus a is the constant. You can keep outside the integral. Now all of you please respond. What is the integration of x square dx? What is the integration of x square dx? All of you quickly respond. What is the integration of x square dx? Here you will get the limits as a to b. Previously we have done integral x dx. Now I am asking what is the integral x square dx? Yes, very good Venkatramana. X power 3 you will get, and denominator you will get, yes, 3 also, correct. X power 3 divided by 3. See, for generalized case, x power n dx. If you are supposed to find integral x power n dx, is nothing but x power n plus 1 divided by n plus 1. Okay. See, if you are having any doubt, just do the derivative of this one. You will get 3x square dx. 3 will get cancelled. X square dx, like that. Okay. So just substitute the limits. So here in the numerator you will get b cube minus a cube. Denominator 3 times b minus c. 3 times b minus c. So now represent this b cube minus a cube is nothing but b minus a into b square plus ab plus a square. I hope all of you studied these standard formulas in your mathematics. Into 3 times b minus a. So b minus a will get cancelled. So you are getting a square plus b square plus ab divided by 3. So this is the expectation of x square. We got expectation of x is average of a and b. Expectation of x square is nothing but a square plus b square plus ab by 3. Okay. Now let us calculate variance of x. Variance of x is nothing but expectation of x minus x bar whole square. Here x bar is nothing but mean, where x bar is nothing but mean or expected value. Both are same. Instead of representing this one, you can represent like this, or otherwise vice versa. Based on the convenience, you can use any of the notation. Expectation of x minus x bar whole square is nothing but variance. So just expand this equation. Expectation of a minus b whole square is nothing but a square plus b square minus 2ab. Minus 2ab. So now apply expectation to each and every term. So you will get expectation of x square plus, see here x bar is nothing but mean, so square of the mean. So mean value is nothing but constant, right? So obviously square of the mean also you will get constant. So that means expectation of that one is nothing but simply that constant. So you can directly write x bar square minus, here once again 2 into x bar is a constant, I am writing outside. Then expectation of x is nothing but x bar. Okay, so expectation of x square plus mean square minus 2 times you are having mean, you have to just multiply. So that means you will get 2 times mean square. So here mean square you are having, here minus 2 times mean square. So that means you will get expectation of x square as it is. Here you will get minus mean square. Okay, if you want, you can represent that notation. Expectation of x square minus expectation of x whole square. Okay, so this is the variance formula. Variance of x is nothing but expectation of x square minus expectation of x whole square, right? So regarding expectation of x square we calculated, regarding expectation of x we calculated. So just substitute those expressions here. Expectation of x square, just now we got a square plus b square plus ab by 3. A square plus b square plus ab by 3 minus expectation of x we got a plus b by 2, and here you are having for overall term square. Okay, so just expand this one. So variance of x is equal to, so first term you can copy as it is, a square plus b square plus ab divided by 3 minus, here a plus b whole square is nothing but a square plus b square plus 2ab divided by 2 square is nothing but 4. Now you can take the LCM. What is the LCM you are going to get for 3 and 4? For 3 and 4, what is the LCM? From 3 and 4 you cannot take anything common, so just you have to multiply, right? So 3 and 4 LCM is nothing but 12. So here 4 times a square plus b square plus ab minus, here 3 times a square plus b square plus 2ab. Okay, right. So here 4a square minus 3a square is nothing but a square. 4b square minus 3b square is nothing but plus b square. Next, 4 times ab minus 6 times ab. So 4 minus 6 is nothing but minus 2. Minus 2. So a square plus b square minus 2ab is nothing but a minus b whole square divided by 12. So if you want this one, you can write as b minus a whole square divided by 12. Okay, because ultimately since you are performing squaring of a term, obviously you will get positive, whether a is greater than b or b is greater than a. Okay, irrespective of that. But in this particular distribution function, we have considered a is the lower limit, b is the upper limit. So obviously b minus a you will get positive. If you consider a minus b you will get negative. But anyway, since you are performing squaring, you will get positive value only. So you can remember this formula or this formula. Yes, good evening Shashi. So that means variance of x is nothing but b minus a whole square divided by 12. Variance of x is nothing but b minus a whole square divided by 12. Okay. So regarding expectation of x, we got average of a and b. Regarding variance of x, we got b minus a whole square by 12. If you remember these formulas, directly you can substitute the values, you will get the answer. Okay. Whatever the derivation I have discussed, okay, if they have given regarding probability density function for generalized case, any expression, so this kind of derivation will be helpful in order to find expectation of x, in order to find expectation of x square, in order to find variance of x. So in order to cover, in order to attempt those kind of questions, so this part of the derivation will be helpful. Okay, right. Now let us calculate for the given question. Let us find the mean value and variance, and here they have given a value as 3 and b value as 6. So expectation of x is nothing but a plus b by 2. A plus b by 2. Here a value is 3, b value is 6. So 3 plus 6 is nothing but 9. 9 divided by 2 is nothing but 4.5. 4.5. So this is the average value or expected value or mean value of the random variable x. Okay. Now regarding variance, so just now we got the formula as a minus b whole square by 12 or b minus a whole square by 12. B minus a whole square divided by 12. So here b value is 6, a value is 3. 6 minus 3 whole square divided by 12. 6 minus 3 is 3. 3 square is nothing but 9. 9 divided by 12. 3 3s are 9. 3 4s are 12. So 3 by 4 is nothing but 0.75. 0.75. So that means the mean value is 4.5. Variance is 0.75. So now if you observe the choices, option B is the correct one. I hope all of you got the correct answer for this question. Whether the derivation is clear for all of you please respond. Whatever we have discussed regarding uniform distribution, expected value, expectation of x square and the variance. For generalized case, I have first derived the formulas. After that, I have substituted whatever the values they have given in the standard formulas. I hope it is clear for everyone. So now let us proceed to the next question. So this is the NIT type of question. That means the answer will be a number, and here we have mentioned you can represent your answer, you will get real number. So you can approximate that one. After the radix point, you can consider to the 2 decimal places. You can round off to the 2 decimal places. So all of you try this question. All of you try this question, and whatever the answer you are getting, you can mention in the chart. See, the previous question is regarding single random variable, okay, and here in this particular case you are having two random variables x and y, okay, and they have given one expression. So this entire expression is nothing but one random process. The previous question is regarding single random variable, and this question is regarding two random variables, okay. They have given a random process like this, xt square plus yt, where x is a Gaussian random variable with zero mean and unit variance. So that means what they have given regarding x, it is the random variable, that is the Gaussian random variable, and they have mentioned regarding that particular random variable, mean value is 0. Mean value 0 means what? Expectation of x is equal to 0. Okay, and variance value is what? Unit. Unit variance means its value is 1. Variance of x is equal to 1. Okay, so regarding random variable x, they have directly given mean value is 0 and variance value is 1. Okay, regarding y, what they have mentioned, y is a uniformly distributed random variable. See, in the previous question also we have considered one random variable. Regarding that random variable, they have mentioned the distribution is uniform. Okay, similarly here regarding y, they have mentioned it is the uniformly distributed random variable. Now, see, in the previous question it is starting from 3 and ending at 6, but in this question they have mentioned the ranging from -2 to 2, -2 to 2. So that means here a value is -2 and b value is +2. A value is -2 and b value is +2. Now can you tell what is the expectation of y or mean value of y? Both are same. So all of you please respond. What is the mean value or average value or expected value of the random variable y? They have mentioned y is a uniformly distributed random variable and they have given the range as -2 to 2. Already we have discussed the formula in the previous question, so just use that formula. See, what is the expected value we got regarding uniform distribution? If you are having a, b or the, it is ranging from a to b, then you will get a plus b by 2. Yes or no? Average of these two. Okay, so here in this case a value is -2 and b value is +2. So that means 2 minus 2 is nothing but 0. 0 by non-zero is nothing but you will get simply 0. So that means, see, here they have mentioned directly the mean value as 0, but here instead of providing mean value 0 directly, but from this particular range you can calculate the mean value. Okay, if you observe the previous question, here they have given between 3 and 6. So when you have taken 3 and 6 average, you got 4.5. But in this case, they have given the range as -2 to 2. So that means if you take the average of those two, you will get 0. Is it clear, Venkatramana? It's not 2, it's 0. Mean value or expected value or average value of the random variable y is 0. Okay, I hope it is clear for everyone. Now, here they haven't given variance, but okay, if you want, we will calculate later. Okay, now here they have mentioned expectation of xy equal to 5. Expectation of xy equal to 5 at t equal to 2 seconds. At t equal to 2 seconds, they have given expectation of xy. Okay, yeah, no issue, Venkatramana. Okay, Then what they're asking? They're asking the variance of random process at t equal to 2 seconds is. Okay, at t equal to 2 seconds, they're asking the variance of this process. Okay, so just substitute t equal to 2. Here they wanted at t equal to 2 seconds. So just substitute t equal to 2 here. See, the given random process is what? Xt square plus yt. So just substitute t value as 2. If you substitute t value 2, 2 square is nothing but 4. That means you are getting 4x plus 2y. See, instead of mentioning like this 4x plus 2y simple expression, they have given one expression like this. After that, they have given t value. Okay, if you substitute, you are getting 4x plus 2y. It is something like cx plus dy. Okay, so just to avoid the confusion, here I have already considered a, b are the constants. Okay, so I have assumed, instead of assuming same variables, I have assumed different variables. Okay, different constants or letters. Okay, where c and d are the constants, you are having the expression like cx plus dy. Okay, so regarding cx plus dy, what they're asking? They're asking the variance. They're asking the variance of cx plus dy. First, let us calculate the variance of this expression. After that, in that expression, whatever the values you will get in the expressions, we will substitute the respective values and we'll do the simplification. Okay, I hope it is clear for everyone up to this point. Now let us calculate, let us find variance of cx plus dy. Okay, so variance of cx plus dy is nothing but, see, here you are having constant c, so that one you will get c square. Okay, c square into variance of x. Okay, c square into variance of x plus, here you are having constant d, square of that one into variance of y, into variance of y. Okay, constant c is there, c square variance of x plus constant d is there, d square variance of y. Now you will get just like a square plus b square plus 2ab format. Okay, so you will get 2 times cd into covariance of the variables x comma y. Covariance of the variables x comma y. Okay, so here see, c value is nothing but 4. C value is nothing but 4. So 4 square into variance of x. So in the question regarding x variable, they have mentioned variance as 1. Unit variance is nothing but 1. Unit variance, so that means variance is 1. Next, d is nothing but 2. D is nothing but 2. Next, variance of y. Variance of y, they haven't given. See, regarding y variable, they have mentioned it is a uniformly distributed random variable, but they haven't mentioned the variance of y. But we can calculate by using which formula? By using this formula. See, just now we have derived regarding variance of uniformly distributed random variable, that is nothing but b minus a whole square by 12. So by using this formula, we can calculate. So here I am calculating variance of y. Variance of y is nothing but b minus a whole square divided by 12. Either you can consider a minus b or b minus a, because ultimately you are performing squaring. Squaring of any term you will get positive only, right? So just substitute b value here, you are having 2 minus a value, you are having minus 2. B minus a whole square divided by 12. So now minus of minus is nothing but plus. So that means 2 plus 2 is nothing but 4. 4 square divided by 12. 4 square is nothing but 16. 16 divided by 12. So 4 4s are 16. 4 3s are 12. So that means you are getting 4 by 3. Variance of y, you are getting 4 by 3. Okay. Now you can substitute here 4 by 3. Next, 2 times c value is nothing but 4 and d value is nothing but 2. Now covariance of xy. Covariance of xy is nothing but expectation of xy minus expectation of x into expectation of y. I hope all of you studied these formulas. Okay. Covariance of xy is nothing but expectation of xy minus expectation of x into expectation of y. Here 4 square is nothing but 16 plus 2 square is nothing but 4 into 4 by 3 plus 2 2s are 4, 4 4s are 16. Now regarding expectation of xy they have given. Regarding expectation of xy they have given the value as 5 at t equal to 2 seconds. 5. So expectation of xy they have given 5. Now can you tell what is the value of this one? Regarding expectation of xy they have given 5. Now can you guess what is the value of this one? Second term. Regarding second term, what is the value you are going to get? All of you please respond. Any guess what is the second term value? Yes, very good Rohit, very good Venkatramana. Yes, see in the question they have mentioned regarding the x random variable they have mentioned 0 mean. Okay, and regarding y random variable we calculated, we got average value as 0. Okay, so here you have to multiply these two. Okay, so in the question they have mentioned 0. Even if you don't calculate this one, 0 and anything is 0. Okay, but here according to the given question we got this mean also 0. Okay, 0 and anything is 0. Yes. Okay, now 16 I am writing as it is. Now 4 4s are 16 divided by 3 plus 16 into 5 is nothing but 80. So 80 plus 16 is nothing but 96. See here you are having 16 by 3. 15 by 3 if you are having, you will get 5. If you are having 15 by 3 you will get 5. But in addition to that you are having 1. 15 plus 1 is nothing but 16, right? So this 16 you can write as 15 plus 1. So regarding 15 by 3 you got 5. Regarding 1 by 3 you will get 0.33. So that means 5.33. Now 96 plus 5 is nothing but 101.33. 101.33. Yes, very good Rohit, very good. Venkatramana, whether you got the same answer? Yes, very good, 101.33. See, the previous question is regarding single variable. Now this question is based on two random variables x and y. Okay, so whatever the formulas in the previous question we have derived, so we have used while solving this question also. Regarding mean of the uniformly distributed random variable is nothing but average of a and b, a plus b by 2, and regarding variance is nothing but b minus a whole square divided by 12. Okay, so I hope it is clear for everyone. So if you are having single random variable, how to find the variance? If you are having two random variables, how to find the variance? Now let us proceed to the next question. This is the NIT, that means answer is a number. So all of you give a try. See here they have given one random process x of t is equal to a plus y of t, where a is the DC component, and they have mentioned mean of x of t as 2 and mean of y of t as 0, and they are asking the DC component in the autocorrelation function of the random process is. Okay, so first of all, see they have given the expression like this, x of t is nothing but a plus y of t. Here, okay, you consider that expression and let us calculate expectation of x of t is nothing but expectation of a plus y of t. Okay, so already they have given expectation of x is nothing but mean value of x of t, they already given that value as 2. Now expectation of, here you are having two terms, individually you can find the expectation of a plus expectation of y of t, and here a is nothing but constant, so expectation of constant you will get the constant only a, and regarding expectation of y, regarding that mean value of y they have mentioned 0, so that means from here you are getting a value is nothing but 2. See in the question they haven't given a value, so just in order to find a value, but instead of directly mentioning a value, but they have given the hint regarding x, regarding y they have given expected values or mean values. Okay, so just if you apply expectation of the given equation, from there after simplified you are getting a value as 2. Yes, very good Rohit, very good, a value as 2. Now what is the question? They are asking regarding autocorrelation function of the random process. In that autocorrelation function of x of t, they are asking what is the DC component you are having. See here you are having x of t signal, so in this particular signal you are having DC component as a. Now the question is in the autocorrelation function how much DC component you are having. Okay, first let us calculate, let us find the autocorrelation function for x of t. Autocorrelation function of x of t is nothing but Rx of tau, which is nothing but expectation of x of t into expectation of t plus tau. Expectation of x of t into expectation of t plus tau. So here expectation of, what is the expression they have given regarding x of t? X of t is nothing but a plus y. X of t is nothing but a plus y. Now see when you are having x of t is nothing but this one, in the place of t you are having t plus tau, so just substitute here, in the place of t you can substitute t plus tau, t plus tau. Okay, now expectation of, see here you are having two terms, here two terms, when you multiply totally you will get 4 terms. A into a is nothing but a square plus a into y of t plus tau plus a into y of t plus y of t into y of t plus tau, y of t into y of t plus tau. Now expectation of a square, see expectation term you can apply for each and every case, expectation of a square plus expectation of a into y of t plus tau plus expectation of a into y of t, then expectation of y of t into y of t plus tau. Now a square is the constant, so that means expectation of a square is nothing but simply a square. Then here a is the constant, expectation of y of t plus tau, here also a is the constant, expectation of y of t. Then now can you tell what is this one? Yeah, thank you, IITN. So can you tell what is this one? Expectation of y of t into y of t plus tau. What is this overall function? Yes, very good, Venkatramana. Yes, very good. See, just observe here. Regarding x function, okay, autocorrelation function is nothing but what? Expectation of x of t into x of t plus tau. Here x of t is the one random variable or random process. Okay. Regarding that, if you are supposed to calculate autocorrelation function, I have considered x of t and then x of t plus tau. Okay. For that product, I am calculating the expectation. That is nothing but autocorrelation function of x of t. In the similar way, in place of x, you are having y. In place of x, you are having y. So that means this entire expression is nothing but autocorrelation function of y variable or y of tau. Okay, this is the autocorrelation function of x, this is the autocorrelation function of y. Okay, right. See, previously when we have calculated a value we got 2, so 2 square plus. See, in the question they have mentioned expectation of y equal to 0. Expectation of y equal to 0. Okay, so here this term you will get 0. Similarly, expectation of y of t plus tau also you will get 0. Okay, or if you want you can make a note for this question. Expectation of y of t they have given 0. Similarly, this one also you can make a note. Expectation of y of t plus tau as 0. Okay, so then this term is 0, then the third term also 0, and last you are getting ry of tau. Ry of tau. Okay, here 2 square is nothing but 4. 2 square is nothing but 4, and then you are having ry of tau. So now if you observe, final equation you are getting rx of tau. Rx of tau you are getting like this. Now can you guess what is the DC component you are having? Yeah, thank you, Ankit. So all of you kindly share this video link with all of your friends so that they also will get benefited from this session. So this subject is common for two branches, EC and IN. So all of you quickly share this video link with all of your friends. Yeah, Venkatramana, you can make a note for this question. See, in the question they have given expectation of y of t as 0. So regarding expectation of y of t plus tau also you can make a note as 0 for this question. Okay, so when these two values are 0, simply you are getting ry of tau, plus after that you are getting 2 square is nothing but 4. Okay, see, just observe the given expression. X of t is nothing but a plus y of t. So here x function, it is a function of time, y is also function of time. Here a is the constant, so that constant is nothing but what? DC value. That constant is nothing but DC value, right? In the similar way, regarding autocorrelation function rx of tau and similarly ry of tau, okay, these two are what? Function of time, and here only 4 is the constant. So that means the DC component present in the autocorrelation function, is 4. Okay, you can make a note for this question. Expectation of y of t plus tau is also 0. Okay, in the question they have given expectation of y of t as 0, and even for y of t plus tau expectation value is 0. Okay, so the final answer for this question is 4. Next question. This question is also NAT, so that means answer will be a number. They have given power spectral density PSD, and here in this question they have, for the time being, they have represented power spectral density waveform only for the positive frequencies. But similarly, in general, for symmetrical purpose, even you will be having the negative f axis, negative frequency axis, and symmetrical waveform will be there on the left hand side. Okay, but for the timing I haven't shown, but okay, for theoretical purpose we will represent the same spectrum. Symmetrical will be there on the negative frequency axis as well. So in this question they are asking calculate the power. They have given power spectral density and they are asking corresponding power. Yeah, Venkatramana. Actually, for the time being, I have shown the power spectral density waveform only for the positive frequency. But for the time being, I haven't shown the negative frequency side. But you will be having symmetrical waveform on the negative frequency axis also. Okay. See, theoretically, see, practically we don't have any negative frequency. But for symmetrical purpose, we will represent negative frequency axis also. Okay. And one more important feature here at 4 and 5, they have given 2 impulses also. You have to consider. Okay, you are almost closer to the answer. Okay, at 4, at instant 4 and 5, you are having 2 impulses, so you have to consider that one also. You are almost closer to the answer. In general, whenever you draw the waveform regarding any signal in the frequency domain, okay, whenever you are drawing the spectrum, in general, we, for symmetry purpose, we will represent whatever you are getting the waveform in the positive x-axis, the similar pattern will be there on the negative frequency axis. But practically, we won't be having the negative frequency. Yeah, regarding the impulses, okay, you have to consider carefully. Okay, I will discuss. Okay. See here, they have given one random signal x of t, one random signal x of t. They have given power spectral density. Okay, for the timing, we have shown only for the positive frequency side, but similar pattern will be there on the negative frequency side as well. Okay, you have to consider that entire waveform. Now, this is the power spectral density. Now they are asking the power of the signal. Okay, so power you can calculate. If you are having power spectral density, you have to perform integration of power spectral density. In general, we will consider from minus infinity to infinity. Okay, so whenever you are having similar pattern, okay, on the negative frequency side and positive frequency side, so instead of calculating from minus infinity to 0 and then 0 to infinity, you will get whatever you are calculating from 0 to infinity, the same area, same integral value you will get for minus infinity to 0 as well, right? So this one you can represent as 2 times integral 0 to infinity power spectral density. Whenever same pattern will be there on the both the sides, on the positive frequency side, on the negative frequency side. Okay, right. Now, see here you are getting in the mathematically you are getting what? Integration. So this integration is nothing but what? Previously also we have discussed area under the curve. Mathematically, whenever you are having integration, so that integration is nothing but simply area under the curve, right? So that means what you have to do, simply power is nothing but 2 times area under this particular power spectral density. Area under power spectral density. That's all. Okay. Now if you carefully observe, here up 0 to 3, you are having power spectral density 0. From 6 to infinite also 0. Only it is present between 3 to 6. Only it is present between 3 to 6. Okay. Now if you carefully observe, between 3 to 6, you are having one triangle. Between 3 to 6, if you observe, you are having one triangle. This is the triangle. And if you observe, you are having one rectangle also. You are having one rectangle also. Okay. Generally, students will consider only this triangle and rectangle. But in addition to that, you are having what? You are having two impulses also. They have mentioned two impulses also. Okay. We have to consider those also. Okay. Right. So power equal to 2 times. See, first let us consider area under this one. Area of the triangle is nothing but half base into height. See, here base is nothing but, here it is starting from 3 and ending at 6. So 6 minus 3 is nothing but 3. In general, we'll consider 3. But here you are having units what? In the order of kilohertz, right? So 6 minus 3 kilo. 6 minus 3 kilo. And then height, how much you are having? 4 minus 2. 4 minus 2 is nothing but 2. So here 2 will get cancelled. Then you are having one rectangle. Regarding rectangle, area is nothing but length into height, okay, or length into breadth. Yeah, very good evening, Nikhil. Very good evening. So here length is nothing but, once again the same thing you will get 6 minus 3k, and height how much you are having? 2 minus 0 is nothing but 2. 2 minus 0 is nothing but 2. In general, students will consider these two. But here you are having impulses, right? See, whenever you are having impulse, area under the curve, area, whenever you are performing integral of the impulse signal, what is the value you are going to get? Regarding impulse, area under the impulse or integration of impulse, what is the value you are going to get? I hope all of you studied in your signals and system subject. Regarding integration of impulse signal or area under the impulse, you will get 1. Yes or no? You will get 1. So since you are having two impulses, you have to add simply 2 times 1. See, regarding impulse signal, area under the impulse, or whenever you are performing integration of impulse, you will get the value as 1. Okay, right. So now 6 minus 3 is nothing but 3. 3k you are having, and here also 6 minus 3 is nothing but 3. 3 into 2 is nothing but 6k, and then 1 plus 1 is nothing but 2. So here 3 plus 6 is nothing but 9. Then simply here you are having 2. Okay, so just multiply 2 with these two. 2 9s are 18k, plus 2 2s are 4. See, here you have to represent the final answer in the order of kilo. So what you can do? This value I am multiplying and dividing with 1000. Now 4 by 1000 you can write it as 0.004. Here 1000 is nothing but kilo. So just add these two, you will get 18.004 kilo. Units are watts. Sorry, here you're having 2, so that means you will get 2. Sorry. See, if you're having 1, then unit impulse is nothing but 1. For unit impulse you will get 1, but here you're having 2 units, you will get 2 plus 2, that is nothing but 4. So here 2 4s are nothing but 8. So here you will get 8. So 18.008 kilowatt. See, in general you will be having like unit impulse signal or unit ramp signal. So whenever regarding unit step signal, that means its magnitude is 1, unit magnitude. Regarding step signal also, unit ramp means it is the straight line passing through the origin. So regarding that slope, you will get 1. Okay. Whereas for unit impulse, the magnitude is not 1. That is the area under the curve. See, in no time you are getting infinite value. Whether practically we can represent that infinite value. In no time you are getting the signal magnitude as infinite. That is nothing but impulse. Okay. But if you do the integration, see, in very short term, in very short time, that particular value you are getting very infinite, right? So if you are performing integration over that small value, area under that curve, you will get 1 if you are considering unit impulse signal. But here they have mentioned the magnitude as 2, so accordingly you have to consider 2. Since you are having 2 impulses, so we have to consider 2 plus 2, that is nothing but 4. So 4 into 2 is nothing but 8. So final value you will get 18.008 kilowatt. 18.008 kilowatt. Is it clear for everyone? Karthik, Venkatramana, is it clear? The final answer here is 18.008 kilowatt. Clear? Yes, very good. See, in general, students will misunderstand regarding the impulse signal. In general, whenever you are mentioning like unit step or unit ramp, so their unit stands for regarding the magnitude of that particular step signal or ramp signal. Okay. Whereas for the impulse signal, unit means the area under the particular impulse signal is the unity. Unity means its value is 1, like that. Okay. Yeah, next question is NIT. See, so far what are the questions we have discussed? Those questions related to the 4th chapter. Now let us discuss the questions based on 5th chapter. 5th and then 6th and then 7th chapter. Yeah, others also please try. Yeah, Venkatramana, you can cross check once. See here, they have mentioned a video signal is digitalized using pulse code modulation. That means PCM, pulse code modulation. The signal bandwidth is 4.5 megahertz. Signal bandwidth is 4.5 megahertz. So that means here FM, that means maximum frequency of the signal is nothing but 4.5 megahertz. 4.5 megahertz. A uniform quantizer with 1024 levels we are having. With 10,024 levels we are having, right? So that means in general the relation between number of levels and number of bits is nothing but L equal to 2 power n. L equal to 2 power n. Okay. Yeah, we'll see which is the correct one. Okay. So all of you please pay attention here. Regarding the number of levels and number of bits, this is the relation. Okay. So they have mentioned the number of levels as 1024, which is nothing but 2 power n. See this value in terms of 2, what you can write? Can you guess? In powers of 2, what is the number you are going to get? 1024. I hope all of you are familiar. Regarding 1024 in powers of 2, what is the value? 2 power, what is the number? Yes, very good. 2 power 10. 2 power 10 is nothing but 1024. So which is nothing but here 2 power n. So that means n value is 10. N value is 10. So that means here n value is 10. That means we are using 10 bits. Okay, the number of bits are 10. Okay, and we are using these bits, 10 bits for each sample. So if you want for generalized case, you can write like this, 10 bits per sample. Now, what they have mentioned, if the sampling frequency is 15% in excess of Nyquist rate. See, forget about this word 15% in excess. Okay, if the sampling frequency is the Nyquist rate. Okay, suppose if the sampling frequency is simply Nyquist rate, then what you will write? Fs is nothing but 2 times Fm. Fs is nothing but 2 times Fm. Nyquist rate is nothing but 2 times maximum frequency signal. Okay, signal frequency, whatever maximum value you are having, just you have to multiply with 2. That is nothing but Nyquist rate. Okay, if they mention sampling frequency is simply Nyquist rate, Fs is nothing but 2 times Fm. But here what they have mentioned, you are having 15% in excess of Nyquist rate. Okay, so 15% excess means what we have to do? Whatever the Nyquist rate you are having, for that Nyquist rate, you are having 15% higher. 15% is nothing but 1 by 100. Is it clear for everyone up to this point? Whatever the sentence is there, if you read the sentence carefully, then you can represent the equation like this. Yes, very good, Venkatramana. Yes, very good. See, if they mention sampling frequency is the Nyquist rate, then Fs equal to 2 times Fm. But they have mentioned 15% in excess of Nyquist rate. Okay, so that means here whatever the Nyquist rate you are having, for that Nyquist rate, if you calculate the 15%, that 15% of the Nyquist rate you are having excess. Okay, right. So 15 by 100 you can write as 0.15 plus 1 into 2 Fm. They have given 4.5 megahertz. Mega you can write it as 10 power 6. 10 power 6. Okay, so this is the sampling frequency. Units you will get samples per second. Samples per second. So 0.15 plus 1 is nothing but 1.15. 2 into 4.5 is nothing but 9 into 10 power 6 samples per second. Samples per second. So 9 into 1.5, if you calculate, 9 5s are 45, then 9 plus 4, that is 13, then 9 1s 9 plus 1, 10. 10.35 into 10 power 6 samples per second. Okay, So this is the sampling frequency. This is sampling frequency. Now what is the question? They are asking the bit rate. Bit rate is nothing but RB. R suffix B is nothing but bit rate. So whatever the number of bits you got, that one you have to multiply with the sampling frequency, N into Fs. Okay, right. So here we got 10 bits per sample. 10 bits per sample. Now Fs value we got this one, 10.35 into 10 power 6 samples per second. Samples per second. So here if you observe, sample is in the denominator, here sample is in the numerator, both will get cancelled. So that means you are getting the units bits per second, and bits per second we can write as BPS, bits per second. Now 10.35 you are having, if you are multiplying with 10, you will get 100.35. See, suppose if you are having 10, 10 into 10 is nothing but 100. Okay, after that you are having 0.35. Okay, and 10 power 6 you can write as mega. So that means you are getting units in the order of megabits per second. So the value is, just 1 second. Yeah, 10.35 into 10 is nothing but 103.5. Sorry. 10.35 into 10 is nothing but 103.5 units are megabits per second. Yes, 103.5. So the final answer for this question is 103.5. 103.5. Is it clear for everyone regarding this question? Karthik, is it clear? Venkatramana, other students also please respond. Is it clear or not? The final answer for this question is 103.5. Yes, I hope it is clear for everyone. So now let us proceed to the next question. This is also NIT, that means answer will be a number. So here the units are dB, decibels. Yes, clear, very good. All of you try this question. Here you have to calculate SQNR, signal to quantization noise ratio in dB. See here what they have mentioned. You're having one message signal, sinusoidal message signal, band limited to 0 to 500 mega, 0 to 500 Hz. So that means from here you are going to get FM is nothing but 500 Hz. 500 Hz. See, the particular signal having the starting frequency as 0, maximum frequency is 500 Hz. So that means FM is nothing but 500 Hz. Okay, is sampled at Nyquist rate. See, in this case they have given sampling frequency as what? Nyquist rate. So that means Fs is nothing but 2 times Fm. Okay, so just substitute 500 Hz here, 2 into 500, so that is nothing but 1000. Units are samples per second. Samples per second. Now, these samples they have given to the n-bit uniform quantizer. Okay, and what they have mentioned, if the bit duration of the signal is 0.5 millisecond, bit duration they have given TB, for each and every bit you will be having some duration, right? So the bit duration they have given 0.5 millisecond. 0.5 milli is nothing but 10 power minus 3. Here units are seconds. See, if you take the ratio, then you will get RB. Ratio of reciprocal of bit duration is nothing but bit rate. Yes or no? See, here bit duration, what it specifies, each and every bit how long you are keeping. Okay, but if you are representing in 1 second how many bits you are transmitting, that is nothing but what? Bit rate. Yes or no? Bit duration means each and every bit how long we are providing that particular bit value. Okay, if you are telling the number of bits that you are transmitting in a second, that is nothing but bit rate. So just you have to take the reciprocal of this one. So that is nothing but bit rate. Yes, very good Venkatramana. Yes, very good. Okay, RB equal to 1 by TB. And regarding PCM, in the previous question if you observe, regarding RB, we have used this formula also. RB equal to n times Fs. Okay, the number of bits per sample, for each and every sample how many bits you are using, and in a second how many samples you are representing. If you multiply those two, from there also you are getting the bit rate, right? So now you can equate both the formulas. RB equal to 1 by TB and this is equal to n into Fs. N into Fs, right? So that means from here what you are going to get, here you know TB value, you know Fs value. So here unknown is n. Okay, so that means n is nothing but, what you can do, you can bring Fs to the left hand side, you will get Fs term in the denominator, right? So that means n is nothing but 1 by TB into Fs. N is nothing but 1 by TB into Fs. Okay, so first let us calculate the n value. TB value here we got, in the question they have mentioned 0.5 milli. Milli is nothing but 10 power minus 3. Next, sampling frequency we got 1000 samples per second. 1000. See here 10 power minus 3 and 1000 is nothing but 10 power 3. So when you are multiplying, equivalent value you will get 1. 10 power minus 3 into 1000, or this 10 power minus 3 you can write as 1 by 1000. 1000 will get cancelled, you will get 1, right? Now 0.5 if you write it as 1 by 2. So that means 1 by 1 by 2, which is nothing but 2. So n value you are getting 2. So that means here number of bits are 2. N equal to 2 bits. Now what is the question? They are asking signal to quantization noise ratio, that is SQNR. SQNR. Signal to quantization noise ratio. Here units are dB, decibels. I hope all of you know this standard formula regarding signal to quantization noise ratio, that is nothing but 1.8 plus 6n. 1.8 plus 6n. Here you will get the final answer in the dB, decibels. Okay, so just substitute n value here to 1.8 plus 6 into 2. 6 into 2 is nothing but 12. 12 plus 1.8 is nothing but 13.8. 13.8 units are decibels. So the final answer for this question is 13.8. 13.8. Yes, very good, Venkatramana. Yes, very good. I hope all of you got the correct answer. So for this question, the final answer is 13.8. 13.8. So the next question, MCQ, that means only one option will be correct. Among the 4 choices, only one option will be correct. So here they have given x of t signal like this, and this particular signal they are passing through the matched filter, and regarding the output of the matched filter, they are asking what is the max value you are going to get and at what time instant you are going to get the max value. So regarding that, you are having 4 choices. You can choose the correct one. See here in this question, they have given the input signal of the matched filter, the expression like this, 5t into u of t minus u of t minus 5, and they are asking output of the matched filter, regarding that the maximum value and at what instant you are getting the max value. That is the question. Yeah, Karthik, part of the answer is correct. So regarding the time instant, your answer is correct. So regarding the maximum value, we'll see. Okay. See, they have given the input signal like this. X of t is nothing but 5t u of t minus u of t minus 5. See, if you for the timing, let us consider the step signal. I hope all of you studied in your signals and system subject regarding step signal. So it is starting from t equal to 0 instant. From t equal to 0 instant onwards up to infinite, you are getting its value as 1. You are getting its value as 1. Okay. Now another signal you are having u of t minus 5. U of t minus 5. So now can you guess? See, here you are having step signal. It is starting from 0 up to infinity. You are having magnitude as 1. Okay. Now can you guess this particular signal from which particular time instant it is going to start? This signal is starting from 0. Now can you guess this particular signal from which instant onwards you will get? Yes, t equal to 5 instant onwards, right? I hope all of you studied in your signals and system subject. Okay, from t equal to 5 instant onwards, you will get, see, whatever the step signal you are having, it is a delayed version. It is a delayed version. Okay, if you are having u of t plus 5, it is like advanced version. It will start from minus 5. Okay, just keep, see here the signal is starting from where? T equal to 0. Okay, now you make t minus 5 equal to 0, then from there you are getting t equal to 5. So that means whatever the value here you are having at t equal to 0 instant, the same value you will get from t equal to 5 instant. Okay, now this is the u of t signal, this is u of t minus 5. Okay, now what you have to perform? You have to perform subtraction operation. Just perform subtraction of these two signals. If you perform the subtraction of these two signals, u of t minus u of t minus 5. See, if you carefully observe, from the instant 5 seconds or 5 units onwards, you are having this signal value is 1, and here also from 5 instant onwards, you are having signal value as 1. So that means 1 minus 1 is what? 0. Okay, between 0 to 5, here you are having value as 1, here you are having 0. So that means 1 minus 0 is nothing but 1. So that means simply you will get like this. Okay, from 0 to 5, you will get value as 1. From 5 to infinite, you will get simply 0. I hope it is clear up to this point. Okay, now what you are having? This entire signal we have to multiply with what? 5t. Okay, see, in general, I hope all of you know that regarding the ramp signal, see, if you are having the ramp signal, you will get the signal like this. Okay, it will start from 0 and it will go up to infinity like this. Okay, but now what we have to do? So if you are considering 5t, then we have to multiply the slope with 5. Simple. Okay, the slope of this signal is 5, right? 5t. This is the 5t signal. Now 5t into this entire signal. So that means when you multiply these two, what will happen? From minus infinity to 0, here both the values are 0. When you are multiplying, you will get 0. From 5 to infinite, you are having here 0, here non-zero. 0 into anything is 0. So that means you will get the signal only between 0 to 5. Only between 0 to 5, right? So that means the resultant waveform you will get like this. The resultant waveform regarding x of t, you will get, just multiply 5t with 1, you will get 5t only. Okay, so this signal will be there only from 0 to 5. That's all. Is it clear for everyone up to this point? Up to this point, whatever the signal they have given, so the equivalent signal in terms of the diagram, this is the signal. Okay. Now if you observe, here you are having 5t, so that means here when you substitute t value 5, 5 into 5 is nothing but 25. 5 into 5 is nothing but 25. When you substitute 0, 5 into 0 is nothing but 0. When you substitute t value 5, you will get 25. Okay. I hope it is clear for everyone up to this point. Now, when you observe this particular signal, it is starting from 0 and you are having up to 5 only. So that means from minus infinity to 0, you are having signal value 0. From 5 to infinite, you are having signal value 0. That means at the output of the matched filter, you can guess, see, regarding the X signal, the minimum value you are having at 0, and maximum value you are having what? See, if you observe here, the range is what? 0 to 25. Okay, when you are having the range 0 to 25, obviously 25 is the maximum. So that 25 at which instant you are getting? At t equal to 5. So obviously when you are transmitting this particular signal through a matched filter, at the output also, you will get the maximum value at t equal to 5 instant only. Yes or no? So with this understanding, so regarding the time at which you are going to get the maximum value, just if you observe this particular part of the question, and with this understanding, you can, okay, just observe the 4 choices. 2 choices you are having 5, 2 choices you are having 10. So straight away you can eliminate 2 choices. Okay. Now among option A, option B, one option will be correct. Okay. Now let us see which option is correct. Here you are having the x of t signal like this, and that signal they have passed through the matched filter. Now at the output of the matched filter, what is the maximum value you are going to get? Okay. So that means what you have to do, output of matched filter is nothing but you have to find the energy. Simple. You have to find the energy of the signal x of t. Energy of x of t. Okay. So here limits will be integral 0 to infinity. Energy is nothing but x square. Square of the signal. But here you are having only the duration between 0 to 5. So you can substitute the integral limits from 0 to 5. Here x of t is nothing but 5t. X of t is nothing but 5t within this interval. X of t is nothing but 5t, and you are having square of that. So 5 square is nothing but 25. 25 is the constant I am keeping outside the integral. So integral limits are 0 to 5. Integral t square dt. Previously also we have done earlier, right? So what you are going to get? Integral t square dt is nothing but t cube by 3. Okay. So here the limits are 0 to 5. So just substitute. So you will get 25 by 3 into 5 cube is nothing but 125 minus 0. So that means just multiply 25 with 125. You will get 3125. And in the denominator you are having 3. Units are joules. Energy is nothing but joules. Units are joules. Okay, for the time being we haven't represented the joules. Okay, but output of matched filter is nothing but energy of the signal. So the units are joules. So 3125 divided by 3. Okay, so this is the answer finally you are going to get, and at time instant 5. So that means option B is wrong. Is it clear, Karthik? Why option B is not correct? All of you please respond. Is it clear for everyone or not? Yes, Venkatram. Yes, I will show. See here in the question, they are asking the maximum value of the output of matched filter. See, for the time being, I am not doing the derivation. Okay. So regarding the output of the matched filter, you will get the energy of the signal. So that particular energy of the signal at t equal, when you have substituted the integral limits, okay. So after finding the final value, so this will be the maximum. See, if you calculate at t equal 0 instant, obviously 0, because up to t equal 0 instant, there is no signal value. So obviously you will get 0. When you observe this particular signal here, regarding x of t at t equal to 5 instant, you're having the max value, that is the 25. Obviously at t equal to 5 instant only, the output of the matched filter also will be the maximum. Okay, right. So that means here you have to simply calculate energy of the signal. Okay, instead of directly mentioning, see, if this question, like say for example in the network theory or the signals and system, they can ask, say for example, this is the signal they have given, and regarding this signal you have to calculate energy. Okay, I hope all of you done the calculation regarding energy of the signal, etc. Right. So this question is regarding matched filter. So regarding matched filter, when you do the derivation, okay, you will get output of the matched filter is nothing but energy of the signal. Okay. Yes, correct, Venkatramana, correct. When you derive the equation, mathematical equation, see here for a matched filter, you are having the input signal x of t, you will get the output. Okay, so that output expression, if you do the simplification, you will get the expression like this. So this is nothing but energy of the signal. Okay, that's why I have directly written energy of the signal. So here in the question they are asking maximum value of the output of the matched filter. So regarding matched filter, if you do the derivation, the final expression you will get like this. So this is nothing but energy of the signal, energy of the input signal, I am telling, energy of the input signal. So this particular energy, if you calculate, when you substitute the integral limits from 0 to 5, so obviously this will be the maximum value. So this is the maximum. See, if they ask in terms of the signals and system subject or in terms of the network theory, okay, so they have given one signal like this. Okay, and if they ask what is the maximum energy of this particular signal, then you will calculate this one. Okay, now this is the communication system subject. So here regarding matched filter, they are asking the maximum value of the output. So regarding matched filter output expression, you will get the expression like this. Okay, so this is nothing but energy of the signal. I hope it is clear now. So the next question is MSQ. That means either one option or more than one option can be correct. So you have to choose all the correct options. You have to choose all the correct options. So far, whatever you have solved with that, can you guess what is the option you are going to get correct? Actually, for this question, you may get more than one option can be correct. So up to now, whatever you might have solved for this question, with the help of that, among 4 choices, which option you are guessing as the correct? Okay, I hope no one haven't done. Okay, no issue. See here, read the question carefully. A voice signal is sampled at the rate of 8000 samples per second. So that means they have given what? Sampling frequency. This is your Fs. Fs value is nothing but 8000 samples per second, right? Each sample is first quantized and then encoded with 8 bits. That means the number of bits are 8. N equal to 8 bits. So they have given the sampling frequency. Fs is nothing but 8000 samples per second and the number of bits used are 8 bits. Okay, right. Yeah, we'll see whether it is correct or not. Okay, so just focus here. So they have given the sampling frequency and they have given the number of bits. Okay, and they are using the PCM, pulse code modulation. The PCM signal is transmitted into free space after modulation. After modulation. Okay, choose the correct option or options regarding the bandwidth. Regarding the bandwidth, and if you observe here, we are having 4 choices, among which 2 choices are related to ASK, that is amplitude shift keying, and 2 choices related to frequency shift keying. Okay, and since anyway this whatever the choices we are having, all the choices are related to bandwidth, obviously among A and B one option will be correct, among C and D one option will be correct, because option A, option B are related to ASK, option C, option D will be regarding FSK, right? So among these two one will be correct, among these two one can be correct, I am saying. Okay, not will be one. Okay, because if the value have specified among these two one of the value is correct, then definitely one among these two will be correct, and similarly here one among these two will be correct. Okay, but you can guess that among A and B one option can be correct, among option C and D one option can be correct, like that. Okay, even you can come to the conclusion that here no option will be correct, here one option may be correct, or here one option can be correct, here no option can be correct, or both the cases, like that. Okay, but obviously since it is a MSQ or MCQ, definitely one of the option minimum should be correct. Okay, right, but from which set we need to see. Okay, for the time being, okay, just read the first 2 sentences. Okay, regarding with the help of first 2 sentences, we already solved some good number of questions earlier, right? See, you are having number of bits and you know the sampling frequency. With the help of these two, can you calculate RB? RB is nothing but bit rate. RB is nothing but bit rate. So regarding PCM, we already discussed earlier, N into Fs. N into Fs. Here number of bits are 8 and sampling frequency they have given 8000. 8000 I am writing it as kilo. Okay, so here number of bits per sample, here samples per second. So that means you will get here 8 into 8 is nothing but 64. 64K. 64K. I hope it is clear up to this point. Okay, and RB is nothing but what? 1 by TB. RB is nothing but 1 by TB. Okay, now what they have done, first initially they used the PCM, after that they have used one modulation technique, after that they have transmitted that particular signal. Okay, now say for example if you are using ASK, if you are using amplitude shift keying, okay, then bandwidth, what is the formula? Regarding amplitude shift keying, what is the bandwidth formula? I hope all of you know the formula regarding bandwidth. Regarding ASK, amplitude shift keying, 2 times 1 by TB. 2 times 1 by TB. So 1 by TB, just now we got this one 64k. So just substitute here. So 2 into 64 is nothing but 128 kilo units are hertz. Okay. See, when you write bit rate, it will be like bits per second. See, per second, if you are writing in terms of frequency, in general, 1 by second is nothing but the unit will be hertz, right? So whenever we are using the bandwidth term, we will write the units in the order of hertz. Whenever you are telling bit rate, we will represent the number of bits per second. Okay, per second. Whenever you are having per second, the corresponding unit will be hertz only. Whenever you are using the bit rate, that time we will represent number of bits per second. In 1 second, how many bits you are transmitting. Okay, in terms of bandwidth, in general, bandwidth units will represent in terms of the hertz. Okay, but both are representing the same quantity only. But based on the context, we will use according. That's all. I hope there is no confusion between the bit rate and bandwidth regarding the units. I hope it is clear for everyone. So that means if you observe these two, so obviously option B is not correct. So only option A is correct. Among option A, option B, option A is correct. Now, yeah, Venkatramana, yes, option A is correct. So regarding option C and option D, let us see. Regarding option C and option D, let us see. See, here in option C and option D, regarding the modulation, we have used the FSK. Okay. So this is the bandwidth when you have used the ASK. Okay. Now regarding FSK, the bandwidth formula is, see, here you are having F1 as in both the choices. F1 is having 5 megahertz, F2 is having 3 megahertz. See, if you don't have this one, but in general, say for example F1, F2, if you are having, if you are supposed to calculate bandwidth, you will subtract lower from larger, right? So in the same way, here also you will get F1 minus F2, But here we are using FSK. So in addition to this, whatever you have considered here, the same thing you are going to get. Okay. Here F1 minus F2 plus whatever the value earlier you got, same thing, 2 by TV. Okay. Now F1 value is 5 mega minus F2 value is 3 mega. So 5 minus 3 mega, then plus 2 times 1 by TB. Just now we got 128 kilohertz. So this one you can convert into mega. So multiply and divide with 1000. So when you multiply with 1000, kilo into kilo is nothing but mega. So here 128 by 1000 is nothing but 0.128 mega. I hope it is clear for everyone. Whatever the value earlier you calculated, same value. But here we have to represent in terms of, here you are having kilohertz, here you are having megahertz. See, obviously if you observe, you will get in the order of megahertz, right? So here 5 minus 3 is nothing but 2. 2 plus 0.128 is nothing but 2.128 units per megahertz. In the order of megahertz, you are getting 2.128. So that means option D is correct. Option C is not correct. Okay, if you remember these bandwidth formulas, so directly you can substitute the values and from there you will get. See, regarding first two sentences, that is related to PCM. After that, regarding ASK and FSK, they have given choices in terms of the bandwidth. Yes, very good Venkatramana. Yes, very good. So the final answer for this question is, you are having two choices are correct, A and D. Both are correct. Regarding ASK, option A is correct. Regarding FSK, option D is correct. So up to here, we have discussed the questions related to the 6th chapter. No. For frequency shift keying, this is the formula. F1 minus F2 plus 2 by TB. Suppose if they don't mention F1, F2, then obviously what F1, F2 values are zeros. Then you will get simply 2 by TB. But regarding FSK, you are doing the frequency shift keying. Okay, you will get F1 and F2. It will be shifted with respect to those frequencies. Okay. Now let us discuss the questions related to the last chapter, that is information theory. Yeah. So this is the MCQ. That means only one option will be correct. Only one option will be correct. So all of you give a try. Yes, Venkatraman. If they don't mention, you can assume it as 0. Yes, I have hidden regarding that one. Now you can see the question clearly. See here, first read the question. A discrete source emits one of the 4 symbols. Here you are having total 4 symbols are there. Okay, it will generate one symbol for every 200 microseconds. For every 200 microseconds, one symbol will be generated. The probabilities of these symbols are 1/3, 1/4, 1/4 and 1/6. Now they are asking the information rate. They are asking the information rate. See, if you read the question carefully, so this particular 200 microsecond is corresponding to what? So just read the question carefully, and the 200 microsecond is given the information related to what? for every 200 microseconds, one symbol is generated. Okay, for every 200 microseconds, one symbol is generated. So if you want to know in 1 second, how many symbols are generated? Okay, so in 1 second, how many symbols are generated? That is nothing but 1 by 200 microsecond. See, just like previous, if they have given the bit duration, okay, bit duration you will get in the order of second. If you take the reciprocal of that one, in 1 second, how many bits you are generating? In the same way, here symbols. Okay, right. So for every symbol we are generating for every 200 microsecond. So that means in 1 second, how many symbols we can generate? Okay, that is nothing but symbols, number of symbols per second, right? So here units you will get number of symbols that you are generating in 1 second. I hope it is clear. How many symbols we are generating in a second? Okay, so this 10 power minus 6, okay, if you bring to the numerator, it will become 10 power 6. That one I am writing it as 1000 into 1000 divided by 200. Here 200 5 times. Okay, 5 into 1000 is nothing but 5000. 5000 symbols per second. See, previously in the previous chapters, we have discussed regarding samples, number of samples per second, number of bits per second, etc. Here we are using the number of symbols per second. Okay, so here we got 5000 symbols it is producing per a second. Okay, now for each symbol they have given the probabilities. For the timing, you can assume this is the probability of first symbol, this is the probability of second symbol, this is the probability of third symbol, this is the probability of fourth symbol. Okay, 1 by 3, 1 by 4, 1 by 4, 1 by 6 they have given, right? Yes, very good Venkatramana, very good. Yes. Okay, so here first let us calculate entropy. Entropy is nothing but average information. Entropy, H is nothing but probabilities into log of probabilities. See, here you have to do summation of, here we are having total 4 symbols. So the range will be 1 to 4. Probability into log 1 by probability. Log 1 by probability, here base is 2. So here you are having total 4 symbols. So that means each and every symbol you have to consider probability and log of 1 by the corresponding probability, like that. Okay, like that you will get 4 terms, you have to add them. Okay, so directly you can write regarding first one, 1 by 3 is the probability and log of, see, P1 is 1 by 3, so that means reciprocal of this one is what? 3. Directly you can write log 3 base 2 plus, here probability is 1 by 4, log of 1 by this probability is nothing but 4. Similarly, here also probability is same, 1 by 4 log 4 base 2. Then regarding the last one, 1 by 6 log 6 base 2. I hope it is clear for everyone. Okay, now 1 by 3 log 3 base 2. So just calculate this value, 1 by 3 log 3 base 2. If you calculate, you will get 0.5283. 0.5283 you will get. Now here 1 by 4 log 4 base 2, here also 1 by 4 log 4 base 2. So both are same, right? So you just multiply 2 with this term. So that means 2 by 4 you are having. Here log 4 you can write as log 2 square base 2. And then 1 by 6 log 6 base 2, this value will get 0.4308. 0.4308. So when you add the first one and last one, you will get 0.9591. 0.9591 you will get. And here 2 square you are having, that 2 will come here. So 2 into 2 is nothing but 4 divided by 4. log 2 base 2 is nothing but 1. Log 2 base 2 is nothing but 1. So 4 will get cancelled. So that means you will get 1.9591. 1.9591. Here units you will get bits per symbol. Bits per symbol. Venkatramana, have you got the same answer regarding the entropy? Here when you calculate 1 by 3 log 3 base 2, you will get this value. Similarly 1 by 6 log 6 base 2, this value. This entire value regarding the sum of the middle two terms, you will get 1. Yes, very good, very good. So here if you observe what they're asking the information rate. See, information means you will be having in terms of the bits, okay. So but those bits we are representing some pattern of bits we will consider as a symbol, right, group of bits, okay. So now if you observe, you're having 5000 symbols per second, here 1.9591 bits per symbol, okay. Now if you multiply these two, from there you will get information rate. From there you will get information rate. So information rate we can represent as information rate R equal to R into H. R into H. So here R value we got 5000. 5000. If you multiply this one with 1.9591, here symbol will get cancelled. You will get bits per second. Bits per second you will get. Okay, so that's why if you observe the choices, you're having the units as bits per second. So just multiply these two. What you're going to get? Yes, you will get 9795.5. 9795.5. Here units are bits per symbol. Yes. Okay, so that means option A is the correct one. Option A is the correct one. Here log 3 base 2 is nothing but log 3 divided by log 2. Similarly, log 6 base 2 is nothing but log 6 divided by log 2. So you will get the approximated values like this. After that, you will get like this. 9795.5. Yeah, whatever you have solved, your answer almost you're getting closer to the option A, right? Here, based upon the number of decimal places you are considering and after the radix point up to how many decimal places you are considering, so accordingly some plus or minus will be there, so no issue. But if you observe the 4 choices regarding 9795, okay, whatever the value you are getting, here 9791 is there, you are getting 9794, right? So almost closer to this one. Okay, based on the number of decimal places you are considering and based on the calculation, okay, based on the calculation of these values, accordingly some slight change may happen, okay. But no issue, the answer for this question is option A. Okay, I hope it is clear for everyone regarding this question. So now let us proceed to the next question. This is the NIT, that means the answer will be a number. So all of you try this question. This is a simple question based on the standard formula. Yes, very good, Venkatramana. Very good. Others also please try. See here, they have mentioned the bandwidth. Bandwidth allotted to a communication system is 10 megahertz. So they have given bandwidth. So bandwidth for the timing, I am assuming I am representing the letter B. So that is nothing but 10 megahertz. Next, they have given the signal to noise ratio. So signal to noise ratio is nothing but signal power ratio of signal power and noise power. Okay, since both the units are watts, so whenever you are taking ratio of the same quantity, that means whatever the units you are having, if the units are same, then obviously you will get constant only. That's why here there is no dB, right? Okay, signal to noise ratio, they have given signal to noise ratio, they have given 15. So if there are no units they have mentioned, so that means it is the normal quantity only. Suppose if they mention dB, then this value is nothing but 10 log signal to noise ratio. Okay, from there you can represent the signal to noise ratio in the normal quantity like that. Okay, now they are asking the channel capacity. So I hope all of you know the formula regarding channel capacity. C equal to B into bandwidth into log 1 plus signal to noise ratio base 2. Here in this formula, signal to noise ratio, normal value you have to represent, not the decimal. Okay, whenever they represent signal to noise ratio in terms of decibel, that whatever the decimal value you are having, that value you have to equate to 10 times log S by N, normal value. Okay, from there if you equate, from there you will get signal to noise ratio, normal value. After that you can substitute. Okay, so this is the direct question. So here bandwidth is 10 megahertz. So 10 into 10 power 6 into log 1 plus signal noise ratio value is 15, base value is 2. 1 plus 15 is nothing but 16. 16 you can write as 2 power 4. So 10 into 10 power 6 log 16 I am writing it as 2 power 4. So 2 power 4 is nothing but you can write as 4 log 2 base 2. Okay, so that means you will get 4 into 10, that is 40. 10 power 6 is nothing but mega. Okay, log 2 base 2 is nothing but 1. Okay, so channel capacity you will get 40 megabits per second. So the final answer for this question is 40. So in this way you can find the channel capacity by using this standard formula. Channel capacity C equal to B into log 1 plus S by N base 2. Okay, whenever they give the SNR value normal, so directly you can substitute. But whenever they give the SNR value in terms of dB, so whatever the dB your equivalent value they have given, that one you have to equate to 10 log S by N. Okay, from there you will get the normal value. After that you can substitute and proceed. I hope it is clear for everyone. So now let us see the last question of this session. So this is the question based on Hamming code. All of you try this question. This is the last question. See, this is the question based on Hamming code. You are having 7-bit Hamming code is received. They have given the 7-bit Hamming code like this. So that means you will be having the message bits and parity bits. Assuming even parity, which of the following option is correct? Okay, so since this question is MCQ, only one option will be correct. So in option A, they have mentioned that whatever the received code you are having, that is correct. In other 3 choices, they have mentioned it is incorrect. And whatever the corrected code is there, they have represented. So among these 4 choices, we have to choose the correct one. Okay, so now you are having 7-bit code. Okay, when you are having 7 bits, that means there will be 4 message bits and 3 parity bits. Okay, for the time being, let us see the regarding parity bits. So 3 parity bits will be there. Okay, for the time being, I have labeled as 3 parity bits. P stands for parity. Here the corresponding position. Okay, since you're having 3 parity bits, 1, 2, 4, like that. Okay, so when you're having 3 bits, you will be having 8 combinations of zeros and ones. Okay, in the 7-bit code, we will place these parity bits in the corresponding positional weights, wherever the positional weight is 1, 2, 4, like that. Okay, right. So when you're having 3 bits, you will get 8 combinations like this. So regarding P1, so we will observe, say for example, just write the corresponding decimal equivalent just for easy understanding. 0, 1, 2, 3, 4, 5, 6, 7. So just observe regarding P1, wherever you are getting ones, just you have to focus that one. So regarding 1, 3, 5, 7. Regarding P1, you have to check those bit positions. Okay, 1, 3, 5, 7. Similarly, regarding P2 bit, wherever ones are there, okay, in the respective bit positions, we have to check 2, 3, 6, 7. 2, 3, 6, 7. Next, similarly, regarding P4, so here you are getting 1 at the last 4 cases, that means 4, 5, 6, 7. 4, 5, 6, 7. Okay, see, when you are having 7 bits, now I am just writing for generalized case, D7, D6, D5, here parity bit 4 is there, then D3, then parity bit 2, then parity bit 1. Okay, when you're having 7 bits, we will put the positions like 7th bit, 6th bit, like that up to 1st bit. Total 7 bits are there, out of which the parity bits are 4, 2, 1. 4, 2, 1. Okay, the remaining bits will be the message. So whatever the given information is there regarding 7-bit Hamming code, so just represent that one. 1011, 1011, 1011, 011, 011. So now this is the Hamming code you are having. Now in the message, whether there is the error or not, so you can check with the help of parity bits. Okay, so regarding P1, so you have to just check these bit positions. Okay, so regarding 1, at first place you are getting 1. Okay, and then you have to perform XOR operation here. At bit 3 you are getting 0, then bit 5, here you are getting 1, then at 7th bit you are getting 1. So just perform XOR operation. 1 XOR 0 is 1, 1 XOR 1 is 0, 0 XOR 1 is 1. Next, similarly 2, 3, 6, 7. 2, 3 is nothing but 1 XOR 0, 1 XOR 0, and then 6, 7, so that means 0 XOR 1, 0 XOR 1. So here 1 XOR 1, once again 0. Okay. Next, last one, 4, 5, 6, 7. 4, 5, that is 1 XOR 1, and 6, 7 is nothing but 0, 1. 0 XOR 1. So here 1 XOR 1 is 0, 0 XOR 0 is 0, 0 XOR 1 is 1. So that means what you got from this, what you are getting, P4, P2, P1. P4, P2, P1 is nothing but 101. 101. Say for example, if you got 000, that means there is no error. Okay. But here you got 101, so that means what? D5. Okay. D5 bit error is there. D5 bit error is there. Okay. It indicates error in the D5 bit. Error in the 5th bit. Okay. So here you are having in the original, in the question they have given that value as 1, and after checking the parity bits, here you got 101. 101 is nothing but 5th bit. So that means there is the error in the 5th bit. So now we have to just correct it. So that bit value you have to make it correct. So since you are having 1, you have to make it 0. If you are having 0 earlier, you can make it 1 like that. So now the remaining bits you can copy as it is 10, 10, 11. Okay. So now just observe the choices. So here in option A you are having received code is correct, but that is wrong. Okay. In the remaining 3 choices you are having incorrect. Yes, incorrect is the correct one. The received code is incorrect. Now the corrected code is 1001. 1001. Here you don't have 1001. Here also no. So that means you can eliminate these two. Now 1001, after that 011. Yes, 011. Yes, we are having the same thing. So that means option B is the correct one. Option B is the correct one. Is it clear for everyone? This is the last question for today's session. For this session, this is the last question. I hope it is clear for everyone. So all of you please respond. The correct answer for this question is option B. So in this particular session, we have discussed the questions related to the last 4 chapters of communication system subject. Okay. So here first initially we started with the single random variable. Regarding uniform distribution, we calculate the expected value or mean value or average, all are same. And then we calculate the expectation of x square and then variance of uniform distribution random variable. And we got the formula as regarding mean, we got a plus b by 2. Regarding variance, b minus a whole square by 12 or a minus b whole square by 12. After that, we discussed the question related to 2 random variables and then 1 constant, 1 random variable like that. Autocorrelation we have discussed. And if you are having power spectral density, how to calculate the power we have discussed. Okay. Regarding PCM, we calculate the bit rate and we have calculated the questions related to the SQNR. Okay. And then we have discussed the bandwidth related to ASK, PSK. PSK and ASK bandwidth will be same. Okay. So that's why I haven't mentioned in the choice. Okay. And regarding FSK bandwidth we have discussed. And then regarding information theory we have discussed the questions. I hope all of you got the confidence regarding communication system subject. In the last class, that is on yesterday, we have discussed the questions related to the first 3 chapters. So in this session, we have discussed the questions related to the last 4 chapters. I hope all of you got the confidence regarding communication system subject. Okay. So all of you please do the revision. Whatever the formulas you are having, okay, chapter wise, you can do the revision of those formulas. And if you use those formulas and from the given data, if you substitute those values, you will get the answers quickly. But for understanding purpose, wherever the formulas are there, you can derive so that even if you forget in the exam, you can quickly derive that particular formula, right? Yeah. Now I will share some information. So this information you can share with your juniors, your friends. Okay. So here in our IMS GATE Academy, what kind of programs we are offering. So regarding that, you can have a glance, okay, and you can share this information to your friends and juniors. it is very much useful for their GATE preparation as well. So here when you go to our website, when you click on GATE, after that you will get all the branches: EC, electrical, instrumentation, mechanical, civil, computer science. And here in our IMS GATE Academy, we are offering classroom programs, that is offline classes, and then hybrid classes, and then exclusive live online, and then we are having self-learning program. So regarding classroom program, so here 750 plus hours, all the classes will go in the offline mode. All the classes are 100% offline. Here you will get 22 to 30 books. You will be having theory books and exercise books. Here you will get 4000 plus practice questions and GATE PYQs, doubt solving portal, my plans sessions. Then you will get 130 plus various tests, and then post GATE guidance. So regarding hybrid classes, here you will be having 2/3 offline and 1/3 online. See, the number of hours will remain same, but out of which 2/3 will go in the offline, 1/3 will go in the online, and remaining features will remain same. And then exclusively live online program, here all the classes will go in the online mode, okay, and remaining features will same. And then self-learning program, so here you will get 400 plus hours of videos in the recorded form, and then you will get all these features. So in our IMS GATE Academy, we will follow this method, LPT method. L stands for learn, P stands for practice, and T stands for test. So whenever you are attending our classes, either physical classes or online classes, so from our classes you will get the concepts, crystal clear understanding, okay, and after that if you are solving from the theory books also, you will get the knowledge regarding each and every concept. After that, if you solve from the exercise book, okay, you will be having 4000 plus practice questions. By solving these questions, you will get the confidence regarding each and every concept, okay, and then you will be having the access of doubt solving platform. And then once if you get the confidence after attending the classes and after solving the exercise book questions, if you want to check your confidence level, okay, regarding that particular subject, okay, at what level you are having currently, and in which concepts you are very much strong, in which concepts you need to prepare, etc. If you want to check your knowledge, then these tests are very much helpful for you, okay. So here we will be having chapter wise test, subject test, then subject wise advanced level, multi-subject test, and full length mock tests. And here the number of questions in each test, duration, and marks are mentioned. Now this is the one of the most useful feature for all the students who are preparing for GATE, okay. So here you no need to pay even single rupee, okay, just come to our website and just enroll, just click on enroll, okay. So you will get 100 plus hours of concept video, 12 chapter tests, 6 subject tests, 6 previous GATE papers with solutions. So all these features you will get for free of cost. So this is, so all of you can share this particular information with your friends and juniors, okay. So you no need to pay even single rupee, and you will get the access of all these features, right? And then here this is the portal you will get whoever students enrolled for our courses, and this is the doubt solving platform. See, in general, whenever you are attending our classes, what are the doubts you might be having, so in general our faculties will resolve in the classes. But whenever you are practicing exercise book questions, that time if you are getting any doubt, okay, or by solving any particular standard book, okay, if you are getting any doubt related to the GATE exam point of view, so you just take the snapshot of that question and post here, just select the subject here and then post the snapshot of the question. So our faculty team within 24 hours resolve your query. So that, say for example, today you got one doubt, tomorrow by at max by tomorrow you will get the solution. So that means you can cross check where you done the mistake or what kind of mistake you have done, okay, what is the correct solution, what is the approach, etc. Everything you will get the clarity. So this is one of the most important feature IMS GATE Academy is offering. This is my plan session. In general, in the classes, some students might be having the shy feeling or fear that whether can I ask some sort of doubt related to the subject or regarding the preparation, etc. Okay, but here you are having one-to-one mentoring sessions. So here the discussion will happen between one student and one faculty. So here students are feel free to ask any query related to the subject and related to their preparation. So our expert faculties will give the proper guidance to the each and every student, the student whoever attend in one-to-one session. Okay, and if the student follow that particular guidance, definitely you will get a very good rank in the coming GATE exam. And you will be having one-to-many mentoring sessions as well. Here many students can participate in those sessions. These are the generic sessions. So that is all about regarding at IMS GATE Academy, whatever the programs we are offering. Now I am going to announce the upcoming batches. As I mentioned earlier, we are having 3 types of courses. So regarding live online, new batch is going to start on January 3rd for EC Electrical IN, Signals and System, for Mechanical Civil, Engineering Mechanics, and for Computer Science, TOC. And on January 7th, Networks will be starting for EC Electrical IN, for Mechanical Civil, FM and Hydraulics, for Computer Science, Operating System will start. And regarding classroom, on January 8th, for EC Electrical IN and Computer Science, the subject Digital Circuits is going to start, and for Mechanical Civil, SOM, Strength of Materials. So these are the completely offline classes, and classes will be at Bangalore. And then hybrid class. So here on January 3rd, for EC Electrical IN, Signals and System, for Mechanical Civil, Engineering Mechanics will start. On January 8th, for EC Electrical IN, Control System will start, and for Mechanical Civil, FM and Hydraulics. And these classes will happen at Vijayawada. So here hybrid classes, 2/3 will go in the offline and 1/3 will go in the online. So regarding any particular program, whatever the batch is going to start for 2024 and 2025, okay, based on your interest, okay, you can enroll for the corresponding program. If you are having any inquiry, you can contact to the corresponding numbers mentioned on the screen. Okay, and please share this information with all of your friends and juniors, those who prepare for 2024 and 2025. So you can inform them to enroll for these programs based on their convenience, so that they can get a very good rank in their GATE exam. Okay, so all of you please share your experience regarding today's session. All of you please share your experience regarding today's session and yesterday's session regarding communication system subject. How many of you got the contents? Yes, I hope all of you got the contents. Okay, and you can share yesterday's session and today's session links to all of your friends also, those who are preparing for GATE exam and who belong to EC and IN branches. Okay, so they also will get benefited by watching these sessions in their later free time. Okay, thank you all for attending these sessions. Thank you very much.